values as we go on in solving problems. Alright, let's now practice. Take one example and see how the amount of heat given to a substance will change the substance from a solid to a liquid to a vapor, and how we do the calculation. Alright, let's start by looking at 1 kilogram of ice at minus 50 degrees Celsius until it becomes steam at 100 degrees Celsius. Let us follow what happens at each step. Now tell me, can you visualize in your mind? You have a block of ice, at negative 50 degrees Celsius. What happens when you supply heat to it? As you supply heat to it, its temperature will increase until it reaches 0 degrees Celsius. So this ice, when you supply heat, its temperature increases until it becomes 0 degrees Celsius. And now you supply heat to it, will its temperature increase? No. Its temperature will remain at 0 degrees until the whole of the ice is melted. So the temperature is going to remain steady until the whole of ice is melted. When all the ice is melted, the amount of heat now you give will increase its temperature. Will increase the temperature to the boiling point of water. Once you reach the boiling point, the temperature will not increase any further. The amount of heat you supply will now be used to change water from liquid to vapor. Alright, let's go through these stages. As heat is supplied to this ice at minus 50 degrees Celsius, its temperature increases to 0 degrees Celsius. Can you calculate the amount of heat needed to do that? What is the amount of heat supplied during that time? You see, when there is a change in temperature, the equation you need to use is the equation that has the specific heat. Q1 equal to mc delta theta, mass times specific heat times change in temperature. Well, that is 1 kilogram times 4,000. I want to make a small change in here. You see, the specific heat of ice is not the same as the specific heat of water. I have used the specific heat of water here. So I want you to change this. The specific heat for ice I want you to use as 2,100. So the amount of heat needed to increase the temperature, so the ice is now at minus 50 degrees Celsius. As you supply heat to it, its temperature is going to increase. And the amount of heat that will absorb during that time is its mass times its specific heat times the change in temperature. That is, it will change from negative 50 degrees to 0. And that will be, you can change this on your own when you change that specific heat. So this is the quantity of heat during that time. Remember, it is ice initially at 0 degrees is now at ice initially at minus 50 degrees has now come to 0 degrees. And now you continuously supply heat to it. Will the temperature change? No. What is going to happen to that ice now? Well, now the amount of heat supplied is used to overcome the intermolecular forces of attraction. The potential energy of the molecules are increasing. The object or the ice is now changing state. Alright. As further heat is supplied, ice at 0 degrees changes to water at 0 degrees. There is no change in temperature. What is the amount of heat absorbed during that time? Q equal to mass times latent heat of fusion. You see that? There is no change in temperature there. The quantity of heat absorbed during that stage, the second stage, mass times latent heat of fusion. The mass is 1 kilogram. Latent heat of fusion of ice is 3.34 times 10 to the 5 joules per kilogram, and that will be 3.34 times 10 to the 5 joules. Now, can you represent that quantity here on the graph? By looking at the first stage. In the first stage, the amount of heat Q1 increased the temperature from -50 to 0. So the ice, all the ice is now here at 0 degrees Celsius, and now you supply this much amount of heat to it so that ice at 0 degrees will now become water at 0 degrees. You can see it is a horizontal line there. All the ice is solid here at 0 degrees, and now this much amount of heat is absorbed to convert all that ice to water without a change in temperature. So here all the substance is now water, but the temperature hasn't changed during that time, and the amount of heat we gave during that time is mass times latent heat of fusion. Okay, now if you heat further, what happens? The temperature now will begin to rise. Alright, once all the ice is melted, the temperature rises until it reaches the boiling point of 100 degrees Celsius. That means here there is a temperature change. From 0 degrees it will rise to 100 degrees Celsius. There is a change in temperature of 100 Kelvin. So what is the quantity of heat absorbed during that time? The quantity of heat absorbed Q3 is mass times specific heat times change in temperature during that time. That will be, mass is 1 kilogram, specific heat of water is 4180 joules per kilogram per Kelvin, and the change in temperature is 100 Kelvin, and that will be 4.18 times 10 to the 5 joules. Can you represent this on this graph? Well, it will be represented by, this is where all the water at 0 degrees, its temperature will increase until the temperature reaches 100 degrees. There you are. So, water increases its temperature from 0 degrees to 100 degrees, absorbing this much amount of heat. Q3 equal to mc delta theta. Now, as further heat is supplied, water at 100 degrees Celsius changes to steam at 100 degrees Celsius. So here, when you supply heat further to it, there is not going to be a change in temperature. Here all the substance is liquid water, and as more heat is absorbed, all that water is going to be converted to steam at the same temperature. What is the amount of heat needed to do that? Q4 equal to mass times latent heat of vaporization. There is no change in temperature during a change of state. Mass is 1 kilogram, latent heat of vaporization is 2.26 times 10 to the 6 joules per kilogram, and that is 2.26 times 10 to the 6 joules, and that is represented by this horizontal line. Alright, so I want you to watch this and learn this very well. When there is a temperature change, the amount of heat absorbed or liberated is mass times specific heat times change in temperature. When there is no change in temperature, that happens during a change of state, the amount of heat absorbed is mass times latent heat of either fusion or vaporization. So what is the total amount of heat absorbed by that ice at minus 50 degrees to become steam at 100 degrees. You add all the quantities Q1 plus Q2 plus Q3 plus Q4, and that will be a measure of the total amount of heat. And you notice you need to apply a small correction to it because I corrected the first quantity of heat. Alright, I'm going to leave it for you to do that on your own. Alright, we have now laid the foundation for doing more problems on using specific heat and latent heat.